JK with an L9H. An L9H is a Gen 4 6.2. It's essentially the same engine as a L94. It just doesn't have air fuel management. The L9H is one of my favorite engines. Not having AFM lifters means it's a very durable engine. They added AFM to most of the Gen 4 lineup in 2010. They did not add it to the 6-liter L96, as that motor is put mainly in heavy-duty trucks. I have an L9H on my own JK. Got about 80,000 miles on it, and it's an excellent engine. This vehicle does have our CAN module in it. Cruise control, Tapshift, brindle, air conditioning are all being controlled through the CAN. This has a Motic module with CAN installed. These installs have really become rationalized over the years. The way we do these installs is to try to keep them as pure as possible. We use all GM parts. We're dealing with the state of California right now for emissions compliance. And one of the rules is you have to keep everything as OE as possible. What that means is you can't modify the calibrations. You can't import engine performance parameters from one calibration into another. You must use all Mode 6 data. We're using factory GM harnesses. In fact, this Jeep I'm in right now is running a completely factory GM harness. The power distribution center, chassis connector, and interior connector are all plugged right in to our integration harness. We're running our own distribution box with fuses and relays that we build in-house, and this allows us to plug the stock PDC connector right into our electronics. The chassis connector simply consists of an O2 sensor, evap vent solenoid, and a fuel tank pressure sensor. Then the interior connector has your data link connector, which includes your CAN wires and your throttle pedal. This JK has our Camaro SS fan that's being controlled completely by the GM computer, not only for coolant temperature, but for transmission temperature and air conditioning condenser pressure. I've been pretty much running about 195 to 198 most of the day, and that was even off-road. I probably hit 205 a couple of times. This fan is just idling. I can't even hear it. Properly programmed, these fans can keep most JKs cool. Improperly programmed, pulse width modulated fans can be a problem, as many of you with Pentastar fans know. So we have several different fan configurations. We can control a Pentastar fan or an SS fan. There are some limitations. The Chrysler programming is not as friendly to fan programming when running it off the GM side. Heck, it's not even friendly when it's run off the Chrysler side, in my opinion. So let's look at some of the other functions that we've included into MoCan. So let's talk about some of the functions built into our MoCan. And we're coding every day to add more functions. Air conditioning. When you turn on your air conditioning, a lot of things happen. A lot of systems are monitored. In this vehicle, the air conditioning is being controlled by the GM side. When you start the engine, you don't want the air compressor to come on right away and start building pressure because your fan's not built up. Speed. So we have a delay, and the delay varies on the different operating systems, but essentially it'll delay the compressor from coming on until the fan can properly catch up. Once the fan is on and the air compressor engages, the condenser pressure is controlled by the cooling fan. The cooling fan is also controlling engine coolant temperature and transmission temperature, so essentially whichever one requires the most amount of cooling overrides the other signals. We're also monitoring evaporator temperature inside the vehicle. This keeps the evaporator from freezing up. If you were just to keep the compressor on all the time, eventually your evaporator may freeze up. We're also monitoring high pressure. The high side pressure, if something happens like your cooling fan were to quit or there's an obstruction in the system, could eventually blow the freon off, or worse yet, blow off a line or whatever. So we're monitoring that, and we shut the compressor off for safety. We are shutting the compressor off with a low RPM cutout, which means if you're off-road and you're wheeling hard and you hit the steering wheel at the same time you hit a bump and the idle dips, the air compressor will shut off so the engine doesn't stall. AC idle bump is built right into the operating system, which means when you turn on the compressor, the GM computer gets a valid AC request, and then it bumps up the throttle body to compensate, so you can't even feel that compressor engage. With our high RPM cutout, if I were going up a hill and I was a downshift and hit 4,000 RPM, the air compressor would cut out. Not only would this give you more power, but we don't want to be spinning those air compressors up that high. Once it comes down to about 2,800, 3,000 RPM, your air compressor would engage again. So we're not just doing simple integration, turning things on and off. We're actually incorporating the factory functionality as the manufacturer intended. The printle in our CAN system is can to can. So we're essentially pulling the current gear signal out of the IMS, the internal mode switch inside of the GM transmission, and then we're telling that to the Chrysler side. The Chrysler side then picks that up, interprets it, and displays it on your dash. It also activates functions like reverse lights, neutral safety, ESP. So it's critical that that be correct. When you do go into the manual mode with our CAN module, you will see that the current gear will be displayed. Tapshift has several different modes depending on your operating system, and we've gone over that. On some of the truck operating systems, you can do second gear launches, or you can limit maximum gear. You might want to go back and look at those videos if you're interested, because I find most customers that drive 6L80s and 8L90s really don't understand how they work and don't get the maximum functionality out of them. You have gear lock, you have sport mode, you have tap shift or manual mode, and we support all those different modes. You can use cruise control in tap, which means if you set your cruise control, you can then tap up and tap down. We have various inputs. This is an early JK, and it had a 12 console installed, so it has bump shift. Now I will say we do run a separate gate for tap shift and drive, which is a step up from what Chrysler does. Basically, Chrysler has park, reverse, neutral, drive. Once you're in drive, you bump that shifter, you're going to shift. With our setup, you can choose to put it into an automatic mode, and it's full automatic, and you have no chance of bump shifting it. You have to pull it back into the manual or tap shift gate to activate that function. Once you're in the tap shift gate, you have several different modes available to you. So like I said, you might want to go back and look at some of those old videos. This build is running not only our CAN module, full GM unmodified harness, but it's also running our easy engine mounts. Our easy engine mounts are bolt-in, require no welding, grinding, cutting. In fact, there's no welding, grinding, or cutting in the entire installation. There's no holes to drill in the firewall, no engine mounts to cut off. The LS engine is relatively small, so the dimensions fit well into a JK. The truck motors do get a little tight up against the firewall, but the easy mounts are adjustable. You can move the engine forward, back, left, and right, and up and down, so it's basically adjustable in 3 dimensions. This can help if you have a large PSC gearbox and a GM drive, so your power steering pump is tight up against the power steering gear, or if you have a Gen 5 engine, and yes, we do support easy bolt-in mounts for our Gen 5 swaps. The cylinder heads are very tall because of the direct injectors, so you can fine-tune it by moving it left and right a little bit if the passenger side is close to the battery tray. There is no mods to the battery tray, firewall, steering shaft, and essentially you shouldn't have to do any mods on the suspension either. If you have a Sport or an X with worn out front springs, and if you have a winch and a steel bumper, the front end's going to sag down. If you put in an iron LS, you're going to be adding 60, 75 pounds, and that just might bring you down close to your bump stop. So you're going to want to put in some beefier springs. On that note, if you are running our billet accessory drive, and we do have the billet accessory drive now for the Gen 4 trucks, and mostly supported on the LS3 applications, If you are running our billet accessory drive, we do put the air compressor on the driver's side lower, just like Jeep did. There's no interferences to the upper control arm. There's no fighting air conditioning lines up against the frame. If you do have a Jeep with stock suspension, you're going to want to run our billet accessory drive. If you run a GM drive and put your air conditioning compressor on the passenger lower, you may have an issue with it contacting the upper control arm. Sometimes it can be a battle to get the hoses attached because the frame clearance is so tight. I know some guys section the frame, but I'm not a big fan of that. I don't like to have any modification. The billet drive works much better. There are some compressor options on the GM drive that we've used that are more compact. The problem with going with the more compact compressors is they don't have as much volume as the larger compressors, and if you have a 4-door JK and you're out here in the west and it's 115 degrees, you really need that capacity to cool the vehicle down quick. I do find that the smaller compressors will do a good job, but it does take a little while for them to cool the cab off. That is an option, but really the billet drive is the way to go in my opinion. The new LS3 billet drive does place the air compressor back off the main belt, so the main belt's about 82 inches long, and you are running a stretch belt from a stock GM Silverado or SUV. The stretch belt does not have a tensioner. The early rear-mounted compressors that GM ran did have issues with the tensioners. They were very low tension, and they actually had some software updates to try to correct that problem, but essentially they ended up just ditching the tensioner and going with a stretch belt, and we find the stretch belts are very reliable. What I really appreciate about this conversion is how stock everything is. The ability to be able to go to a dealership, whether you're in Las Vegas or Dubai, order a part number for an engine harness, install it on your vehicle and plug it in is huge. I'm not sure that's ever been done in an engine conversion to the level that we have done it.